Today I want to talk to you all about Perovskite solar cells, what they are, and their positives and negatives and how they kind of connect with solar energy. So first we need to understand a little bit more about solar energy. It is the harnessing of the heat and light off of the sun and converting those things into thermal and electrical energy. The process goes as follows, where the photons will come from the sun and they will land on the solar panels on top of your home or in your fields, wherever you have your solar panels. Once they land, there are generally two layers, a negative section, a negative silicon-based section, and then a positive-based silicon section. And in between those two is a junction. What will happen is those photons will come down and will strike a silicon atom in that junction. From there, they strike off an electrical portion, a negative electrical portion, and then a positively charged portion. From there, the negative charged portion is pulled more towards the upper part, which is where the negative silicon portion is, and the bottom is the positive portion. From there, you can connect wires from those layers to a battery or a generator or anything like that, and create an electrical circuit where energy can flow. And this will continue to go as long as there's sunlight hitting those panels and as long as everything is working according to what they should be doing. Now, the average silicon-based panel has an average efficiency around 15 to 20%, which may not sound like a lot, but it's the best that scientists have been able to produce up to this point. They can vary quite a lot based on how they're produced, and if you find any defects in any part of the panel. It's not very cost effective in trying to remove those defects, so it's not the most beneficial in that sense. And this is where people have been turning more towards perovskite. Perovskite is a general term for a mineral with a specific structure that contains a lot of calcium, titanium, and oxygen. Perovskite itself is one of the most common minerals on Earth. And though it's very common, it's very difficult to mine and to get. So scientists have been coming up with ways to synthesize the material using cheap and abundant chemicals. And this is kind of where we talk a little bit more about it. Perovskite itself is very defect tolerant and very electrically conductive. This is what makes it such a more desired form for solar energy and solar panels. Like I said, the average efficiency rating of a silicon-based panel is around 15 to 20%, but scientists have been able to theoretically prove the efficiency of perovskite solar cells between anywhere of 38 to 40%, which is quite an increase there between those two. One of the main benefits with it, as like I said, it's so efficient. And in that regards, the cost return can be a lot more and a lot quicker. A lot of people have stated that the potential for your return, to make your return on that investment, could be anywhere, instead of years where it normally is with a silicon-based panel, it could be anywhere with months with these perovskite solar panels, which is incredible, being able to make your return within a year of being able to get these solar panels and make that money back. It's truly amazing that we're able to potentially do that. And like I said, even though it's quite amazing, there is still the reason that it is a hypothetical issue. We don't fully know how much it really can give us back, and that's where a lot of this testing is still going on, continuing to find substances of ways of utilizing it to fully get that efficiency up so that it becomes a more beneficial part of solar energy. But for right now, silicon-based panels are normally the best that we have, and they're normally the most prized. So since that is one of the more difficult things, also perovskite can degrade quite quickly. So they're trying to come up with ways to make it more, making it last longer, increasing its longevity, and making that a much more beneficial aspect to solar energy.